Okay, today we continue with the estimated of estimation actually using the maximum likelihood method. But before that, I nak you recall balik the previous lesson, which is the objective of the factor analysis. Before we go through or we go in depth in this topic, I want to stress about the objective of factor analysis and the research questions that always we deal with when we are doing the factor analysis. Okay, so basically we have three general goals to conduct the factor analysis, which is the first one is data reduction. As you know, our intention is to minimize the variables using the factor analysis. For example, we have a set of variables, ada banyak large set of variables, and we want to reduce it with some of the factors. Okay, we have p variables and we will reduce it to the k groups ataupun k factors, dinamakan k factors. Okay, and then okay, how to we reduce that? We're looking at the correlation, right, between the variables. Okay, which variables that have the high value of correlation among the other variables, so that variable will group together. Okay, and tengok pula the other variables that can be grouped with the other variables. Okay, and then that group of variable can be grouped as another factor. Okay, itu so kita ada dua lah kat situ, bersama ada nak boleh gunakan principal components yang daripada previous lesson. Okay, yang kedua, we also can describe the relationship. Okay, we can describe the relationship whether which variables having the give the most contribution to the factors. Also, we can describe the relationship. Okay, yang ketiga ni, in the next chapter, test the theory about the relationship. Okay, so for example, here, suppose that a bank asks a large number of questions about a given branch. Consider how the following characteristic will be more parsimoniously represented by just a few construct ataupun factors. So actually, before this, dalam previous lesson pun, I dah explain about the example. Dalam principal component is also the same example, tapi I nak stresskan lagi sekali lah. Okay, let's say we have this, all of this adalah the variables. Okay, friendly of staff, time spent, assistant. So we have set of the variables, and according to the correlation value and also the factor loading, kalau kita gunakan factor analysis, kita gunakan factor loading, we can group the variables into some of the factors. Okay, let's say these three will be in the first group. Okay, the other four will be in the second group. The other three will be in the third group. Okay, so how we group this? Kita gunakan factor loading ataupun the value of correlation. Kan? So dalam factor analysis kita akan gunakan factor loading lah. Okay, so we have 3M, okay, ataupun 3 factors that we can develop to represent all of these variables. Okay, so macam mana nak tahu berapa banyak faktor tu? You dah belajar sebelum ni dalam principal component. Sama ada kita gunakan value of lambda more than 1. So kita tengok how many lambda that have the value greater than 1. So kalau ada 3 value lambda greater than 1, so our M ataupun number of factors that can be created will be 3. Okay. Ataupun boleh gunakan script plot. Kan? Ataupun satu lagi boleh gunakan value of total sample variation. Kan? Okay, daripada situ we can know how many factors that can be developed for this all of these variables. Okay, and then next you also can name the new factors. Okay, kita ada 3 tadi factors, so you kena namakan a unique name to represent the variables in that factor. So kalau yang ni friendly, time spent, assistance, it can be we rename it as service. Distance, hour, operation, availability, proximity to other store, we can name it as convenience. Okay, so the name of this new factor ni depends pada researcher nak represent that variables according to the unique name. Okay, so dalam example nanti you need to a lot of questions ataupun biasalah normally the question will ask you to name the variables, the new variables to represent all the name the factors to represent the variables. Okay, so usually the research questions that can be answered using the factor analysis is like, for example, how many interpretable factor exist in the data, or how many factor are needed to summarize the pattern of the correlation. So yang ni you akan tengok how many factor that can be needed to summarize ataupun to summarize the the variables or correlation. What does each factor mean? And then interpret. Okay, you can interpret the factor mean. Boleh juga gunakan factor analysis. What is the percentage of variance in the data accounted for by the factors? Okay, yang ni you cari total variance, total sample variance, and then from that you can know whether how many factors. Ataupun you can also interpret the value of the total sample variance, which is how many percent of the total variance represent by the how many principal component or how many factors. Which factor account for the most variance? Okay, you can find using the value of correlation. How well does the factor structure fit a given theory? Okay, yang ni dah belajar sebelum ni. Okay, you need to estimate the value of loading factor dan juga specific variance, and then lastly you find the matrix of correlation, and from that you can know whether the factor ataupun the model yang you ada tu fit the data or not. What would each subject score be if they could be measured directly on the factors? Okay, this one ni belum masuk lagi lah. Kita akan tengok dia punya score untuk measure on the factors. Okay, you can nanti last kali I akan explain balik the start in the factor analysis from the start, daripada awal sehingga akhir at the end of the chapter nanti. Okay, so actually we have two types of factor analysis. Exploratory factor analysis dipanggil EFA, ataupun confirmatory factor analysis dipanggil CFA. So apa yang you dah belajar sebelum ni, kita gunakan principal component kan. Hari ni nak gunakan maximum likelihood method. Yang ni kita hanyalah we explore the data, which is dinamakan exploratory factor analysis. Okay, it used in the early stages of research to gather information about the interrelationship among a set of variables. So yang ni yang kita tengah buat sekarang ni, yang dah belajar sebelum ni adalah EFA, which is the exploratory factor analysis. Okay, confirmatory factor analysis adalah more complex and sophisticated set of techniques used later in the research process to test the hypothesis or theory. Okay, so untuk confirmatory factor analysis, it will be done after we do the exploratory factor analysis. So dalam EFA kita akan stages yang mula-mula, the early stages. We gather the information. We have all the variables and then we group it into the several other factors. Itu adalah EFA. Okay, and then we test for the reliability. Kita boleh test whether data tu ada outlier ke tidak. Itu baru EFA. Untuk confirmatory factor analysis, when we already confirm that the variables is belong to the corresponding factors. Okay, itu adalah confirmatory factor analysis. Biasanya kalau if the researcher using the questionnaire from the other researcher, actually itu adalah confirmatory factor analysis. Sebab questionnaire yang dia dah ambil tu dah dibuat EFA oleh researcher yang lain. So ianya dinamakan confirmatory factor analysis. Kalau researcher tu start daripada awal, dia ada just a bulk of the variables ataupun a bulk of the questionnaire yang tak tahu yang belum dibuat structured lagi, dia punya variables to belong to which factor. So itu adalah exploratory factor analysis. Kalau dah ada questionnaire yang dia dah separatekan according to the factor, itu adalah confirmatory factor analysis. Okay, alright, itu adalah dia punya introduction about the factor analysis actually. So from the previous lesson, you have learned what is the orthogonal model, okay, which is the orthogonal model tu adalah very important for factor analysis, that you have learned ataupun you have identified which one is, what is the model, what is X matrix, what is F matrix, which is a factor loading, and then what is the psi kan, the notation untuk specific matrix, and then you know about the assumption of the model, expected of F, expected of epsilon, the covariance between F and epsilon is 0 and so on. Itu semua the assumption of the model, orthogonal model that you need to memorize. Okay, and then you are using the principal component method to estimate the value of loading, factor loading, and also the specific variance. Okay, other than that, you know how to use the formula to find the commonalities. Okay, so from that we can use the estimation, the value of estimation for the factor loading dan juga specific variance to develop the residual matrix. From that you can know whether your model tadi represent ataupun a good fit for the data or not. Okay, so sebelum ni gunakan principal component method. Okay, satu lagi adalah maximum likelihood method. So actually dia punya konsep sama je, model dia sama je, cuma method kenapa yang berbeza adalah dengan maximum likelihood method ni, when we find the value of lambda, which is the eigenvalue, dan normalized eigenvector, itu saja berbeza. Kan sebelum ni kan you dah belajar cara nak dapatkan lambda dan juga normalized eigenvector. So kalau we find the lambda and the normalized eigenvector using the maximum likelihood method, we will get the different answer for lambda dan juga normalized eigenvector. Okay, so tapi yang lain sama. Cara you nak estimate the L matrix, which is the factor loading, and also the specific variance and the commonalities is the same. konsep yang sama sahaja sebenarnya. Yang berbeza hanyalah lambda dan E. But usually for this topic, lambda dan E diberi. Okay, biasanya diberi sebab dia complicated lah untuk you nak kira satu-satu. Okay, so just you need to know at first macam mana you nak isi table ni. Kan nak isi table ni. Okay, first you need to know how many factor that you need to develop for the model. How many factor? F1, F2, F1, F2, F3 or F1 sahaja ke? Okay, so how to do that? So you need to see the simplest one. You need to see whether how many eigenvalue that having the value more than 1. So kalau ada 3 lambda yang ada value more than 1, so you punya M ataupun number of factors will be 3. Kalau more than 1, kalau lambda number of lambda more than 1 is 2, the value is 2, so you can develop 2 factors. Okay, yang lain sama. Okay, saya mula daripada sini lah. Benda lain sama maksudnya kat sini. Maksudnya kat sini kalau cara you nak cari hash pun sama. Okay, the formula kan, dia nak cari hash I square, which is the commonalities, which is the you need to square the factor loading for each of the variable that you have. So you akan dapat hash I square. Okay, and then nak cari proportion pun sama. Okay, the commonalities divide dengan total of the variance. If we use big sigma to find the lambda. If we use rho, which is the correlation matrix, it will be commonalities divide dengan P. Okay, which is the total standardized. Okay, it will be P. Itu saja beza dia. Okay, and then remember, waktu you nak buat table ni kan, you nak susun F1, F2 ni yang mana satu kan. Okay, so you akan tengok sepatutnya kat sini ada satu lagi value lambda. Okay, lambda, susun lambda yang the highest lambda first. Okay, let's say you dapat lambda 2 kan, kat sini kan you dapat lambda 2. Lambda 2 pula. You dapat M equal to 2, which is lambda that more than 1 is 2. So you nak susun dekat sini yang mana satu F1, yang mana satu F2. It depends pada you punya lambda tadi. Kalau lambda you kat sini should be the highest lambda. Kat sini will be the second highest. So lambda dekat sini yang ditulis kat sini lambda hanyalah untuk lambda yang more than 1 saja. Betul? Okay. And then you can find the factor loading. What is the formula for factor loading? You dah belajar sebelum ni, which is the square root of lambda 1 multiply E I J. Betul tak? Okay, so formula yang sama. Boleh cari factor loading for each of these column. Okay, column of factor loading. Okay, and then kat sini dia tunjuk beza antara principal component dan maximum likelihood. Tapi nak cari maximum likelihood sama saja dengan principal component, as long as you ada value lambda dan juga eigen vectors. Okay, so nak cari kat sini specific variance. Here you need to find the commonalities first. Remember, commonalities adalah value of L factor loading square plus this factor loading, you akan dapat hash I square. So untuk dapatkan specific variance, 1 minus hash I square, you akan dapat 0.42. Okay, sama, caranya sama saja. Okay, and then these two pun sama juga, which is the total. Kat sini dia buat total standardized sebab digunakan value R tadi, correlation. So dekat sini will be apa ni, li square s, okay, ni formula kan, li square sehingga nj divide dengan p. Okay, sebab kita gunakan standardize ataupun gunakan R, so kena bahagi dengan P. Kalau gunakan big sigma, you akan bahagi dengan S. Okay, so you akan dapat this results. Okay, akan dapat this results. Example 9.5 ni. Okay, so once we have estimate the value of loading dan juga specific variance, we can find the value of residual matrix. Kan, nak cari residual matrix. The formula is R minus, remember from the previous lesson, R minus L factor loading, matrix of factor loading, multiply the transpose of the factor loading matrix, L multiply L transpose, minus dengan specific variance. Okay, remember the specific variance, matrix of the specific variance adalah the main diagonal of specific variance. Okay, the main diagonal saja yang ada value of the specific variance. Yang lain-lain dia punya entry is 0. So when you apply the formula to find the residual matrix, ini beza antara residual matrix of BC dan juga ML. Okay, maximum likelihood. So seems that the value of the residual when we are using the maximum likelihood is smaller. Okay, next is factor rotation. It is applying the orthogonal transformation on the initial loadings. Okay, we make the transformation on the loading matrix. Okay, matrix L kan, loading matrix L. Okay, before this L kita akan transform menjadi LT. Okay, but no need for you to memorize the formula or to generate the value of LT, but just you need to know why we are doing the factor rotation. Okay, we will do the factor rotation usually when we cannot define or we uneasy for us to identify which variable belong to which factor. Okay, kita boleh tahu susah nak tengok dia punya value of R maybe seakan-akan sama ke, maybe the value of R is very small, so we cannot know whether these variables belong to which factors. Okay, so if that happen, we will doing the factor rotation ataupun transformation on the loading. Okay, so when and why? Okay, most of the rationale for rotating factors come from the Thurston and Kettle, who defended its use because this procedure simplifies the factor structure and therefore makes its interpretation easier and more reliable. So when we are using the factor rotation, the procedure will be simplified. So dia punya value of R tu akan jadi lagi clear lah. So dia akan simplify kita punya factor structure, and then from that it is easy for us to interpret or select the variables that belong to which factor. Okay, we have two types of rotation actually. Dipanggil orthogonal rotation and juga oblique rotation. Okay, if we know that our data ataupun our factors are independent, so we will use the orthogonal rotation. When the data ataupun all the factors are correlated, okay, among each other, so we will use the oblique rotation. So nak pilih, okay, the choosing of the orthogonal and oblique is depends pada researcher. Okay, so the value of loading ni nak guna rotation, nak buat rotation ni, just we are using the software, just klik saja you nak gunakan rotation yang mana. Okay, you tak nak kira manually tu susah lah, very difficult. So we can use the software. Ada macam-macam software. Okay, we can estimate the factor, the new factor loading ataupun dipanggil rotated factor loading. Okay, so you just need to know when your data are independent and when your factors are independent, so you need to use the orthogonal rotation. When your factors are correlated, you need to use the oblique rotation. So orthogonal ada 3, varimax, quartermax and equalmax. It depends pada you nak klik yang mana. So biasanya kita akan klik varimax saja. Output pun biasanya akan keluarkan varimax. But it depends pada researcher actually nak guna yang mana. So actually dia punya ada details dia lah, varimax ni macam quartermax ni macam mana, equalmax ni macam mana. So maybe the next level, the higher level, you akan belajar lagi. Okay, so oblique rotation ada 2, direct obliement dan juga promax. So biasanya kita akan gunakan direct obliement dalam SPSS punya. Okay, so this is the details of the varimax, quartermax dan equalmax dan juga oblique rotation. Okay, dalam SPSS dipanggil obliement. Okay, kita tengok contoh. This is example 9.8 from your textbook. Okay, page 505. This is the correlation matrix given. From the correlation matrix, so initially actually we can observe kan which factor correlated among them. Okay, so daripada sini kita susah nak tengok kan. Di sini 0.5, 0.4, dia punya value of R tu rendah kan. So because of that, okay, ini dia punya estimated factor loading. Okay, kalau you tengok di sini kan, daripada factor loading ni kita boleh tengok kan which variables that can be grouped together, okay, for factor 1. Then which variables can be grouped together and then name it as F2. Kan? So daripada sini kalau you tengok dia tak berapa firm. Kan? Di sini 0.7, 0.7, 0.5, but here tak ada value yang besar, 0.4, 0.4. So it's confusing. So in this case ada 2 situasi ni using R dan juga guna factor loading. We cannot identify the variables that can be grouped together for 2 factors. So we can decide to doing the factor rotation. Okay, you can click the factor rotation sama ada nak guna orthogonal ataupun oblique. Okay, and then the output will be keluar lah. Ini dia punya contoh rotated factor loading, dia punya output. Okay, bila buat rotated factor loading, okay, you boleh tengok di sini for the first factor. Okay, untuk variable 4, 5, 6, 0.78, 0.75, 0.6. Okay. Okay, yang lain small, very small kan, jauh beza. Tengok pula faktor yang kedua. Kan? Okay, yang ni lagi clear, 0.5, 0.4, 0.5. Kalau tadi dia kat sini nilai negatif. Kat sini 0.2. Sini pun 0.2, confused kan? But here is clear. 0.5, 0.4, 0.5. Yang lain semua value 0.0 something. So it's clear that variable 1 to 3 goes to the second factor. Variable 4, 5, 6 goes to the first factor. And then from here you can decide these 3 variables can be named as what. These 3 variables can be named as what. Okay. Okay, the next example, benda sama je I nak explain. Example 9.9. Okay, page 508. Okay, kalau gunakan estimated factor loading here. Okay, 0.78, 0.9, 0.8 bolehlah kat sini. But here 0.82, 0.75. But if we use the rotated factor loading, it's more clear, right? 0.9, 0.8, 0.7, 0.99, 0.89. Okay, so from here we're saying that when we are using the rotated factor loading, the results ataupun it is easier for us to make the interpretation about the variables that going to group in the for the factors. But kalau you tengok dia punya value of proportion, total of proportion, the value is the same. Maksudnya kita akan dapat result yang sama. Okay, akan dapat result yang sama. Maksudnya kalau gunakan estimated factor loading pun kata kita ada dua factors juga, two new factors. Okay, so kalau gunakan rotated pun resultnya 2 juga, 0.93 kat sini. Okay, 2. Okay, so we can name the new factors yang kita dah groupkan the variables. Okay, sama saja example 9.10. Okay, if you can see, okay, kalau kita tak buat rotated, it is here the value kat sini seakan-akan 0.6 juga, 0.6 juga, 0.6 juga. Okay, but the second one kat sini kat sini 0.5. It's not easy for us to groupkan the variables according to the which factor, kan. So bila buat rotated, it's more clear, very clear. 0.6, 0.8, 0.6 can be grouped as one factor. 0.5 and 0.8 can be grouped in one factor. So we have two factors. So from this we can name the factors that we developed tadi. Okay, itu saja sebenarnya untuk factor rotation. So rotated estimated factor loading ni we can construct from the SPSS software. Alright, that's all for this time.